Well, good morning. My name is Dean Milton. I'm actually from Canada, a university instructor, and I'm here at TecQuipment this morning looking at some new products. I'm in the process of replacing my existing hydraulic benches with the new H1F digital hydraulic bench. So I'm having a good chance to have a tour of the facilities here where they manufacture the TecQuipment. I presently have this experiment, which we're demonstrating today, which is the H8. It's the impacted jet experiment. Uh, did you ever wonder why turbines and pumps have curved blades? Well, what we do with this instrument is we prove to our students that we actually get twice the force out of a hemispherical cup than we did if we had a flat plate. The reason for that is on a centrifugal pump with a curved blade, when the water jet hits the target, it discharges at 180 degrees. If we had a flat plate in here, for example, the discharge would be at a 90 degree. Visually, with a maximum flow rate here of about 30 liters per minute, we're getting a delta Y of about 150, keeping this balanced. As I decrease the flow rate, you can see to keep the system balanced, I have to move this jockey mass a certain distance back to keep my system relatively level. So for example, if I had a flat plate installed, visually at a maximum flow rate of 30 liters per second, my delta Y would probably only be half the distance that it is for the cup, proving that a cup target is twice as efficient for producing a target force than a flat plate. So that's the idea behind this experiment, which I use in my second year engineering fluid mechanics course.